we have a project where we've got a client who's ordered a custom threshold from us, and this video is to discuss and document basically the process of creating this custom threshold. Let's do that now. Okay, we're really in the final passing now. Clamped down pretty doggone well, I'd like to think. No. We're going to have to go back and run that just a little bit deeper. We're not all the way through. We are not all the way through. Being real clean right there. Excellent. Now let's see what we have. This looks spectacular. This is the first threshold. First one ever made. It's 1/16 of an inch too wide, and I know how I did that. I know what I did. That won't happen a second time. It looks a lot more awful than it feels. This is all very clean. Looks really nice. That's just incredibly impressive. Beautiful. Beautiful. Probably do a little bit of cleanup on the top side of this. I'm thrilled with this. Probably clean off the leading edge a little bit. I will. I'm going to give this some TLC tomorrow, and then I will show you the finished product before we're all done. If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. So it's the next day, and the threshold is done, and other than a couple of odd eccentricities that caused a learning experience, really, about the threshold, it's done. I'm going to put some TLC into it, file off a couple of odd corners. There was something that was occurring. The width, if you recall, the width was off by a 16th at the end of the day. It's a 16th too wide. That's going to be fine. This project's been going on for a month. It took a month to get the aluminum, and once the aluminum was received, we were the tool pathing was done. We were waiting for material to come in. And if you recall the depth of the client's application, a 16th is completely unimportant in this instance. So if you recall, I'm a 16th off. Well, I know why. It occurred to me either yesterday or this morning why. The piece has to be repositioned. You've got the inherent repositioning inaccuracy when you place something down, you machine it, then you have to flip it over, and you have to place it down and then machine it. And the dimensions from the top and the dimensions from the bottom need to reference the same 0 point. Well, the mistake I made was when I trued the front edge of the threshold, one of the very first things I did, I got the aluminum on the bed to the point where all I was going to do is just skim the front of it, knowing that I have a true edge. Okay. Did all the machining, flip the piece over, and at that point is where I made the mistake. I used a 3/8 diameter bit to reference the front of the plate initially. When we pulled it out, flipped it over, put it back in, I used a 1/4 inch diameter. I used that 1/4 inch diameter bit to reference where I positioned the plate on the tool for 0, 0, knowing what my 0 on the Y would be. And so I'm off half of the diameter of the difference between the two bits. 3/8 minus 1/4 divided by 2 is a 16th. That's why I'm off the 16th. So that trick in the future needs to use the same diameter bit when referencing it. So that's something learned. So let me show you the threshold. Here it is. As far as I'm concerned, it looks phenomenal. I mean, for my very first project ever done with aluminum, quite frankly, while I've owned CNC equipment in the past, it was always more so in a sense of it was my company, and I'm in sales. And while I worked in the shop a lot, it wasn't what I did 8 hours a day. So I knew how to use one of the two CNCs, the multi-axis ATC SCMI that we had. I never learned how to use that. There was no Vectric, I think, back then. Anyway, so the threshold looks really great. So some of the key components, obviously the leading edge. Okay, so that's handicap compliant. That's an A117.1. That 140-degree angle does not violate the rise over run restriction. So I know I'm good there. The face of this also doesn't violate ADA requirements because it's not greater than a 1/4 inch. The fluting on the top worked out really well. What I will do next time is that's a 16th of an inch. I won't do that again. I'll do 50 thousandths or experiment. I think it looks great, but I think it's also too deep. Okay? Because I'm off a 16th of an inch, my back end, I've got a couple of little artifacts here that I've got to file off. I've got one on either end. So I V-groove cut this first. I think what I'll do next time is I will not V-groove first. I'll V-groove second. Again, that little giddy up that's here is because the piece was actually curling up ever so slightly. Machining on the backside looks, I mean, it has this pattern design, but it's just milling marks is all it is. Very smooth to the finish. And I think the important part about what I learned was somehow when the tools were set up initially, our feed rate was way too high, like 4 inches a second. And getting it down to 2.5 inches a second and
don't take anything I'm about to say about the RPM, about the feed rates, and the chip load as anything other than, so far what I know is apparently substantially thinner pass depths, substantially thinner, and I wouldn't say slower, but 2.5 or 2.9 or some in the 2 inch per second range. And I'm getting RPM in the feed rate out of the Onsrud catalog where I'm looking for chip load. So the back of their solid carbide metalworking catalog, they have two catalogs. One is solid carbide for metalworking. They've got chip loads in the back, and I'm using those chip loads. This is an absolute bit in their catalog. The problem is that V-Groove bit, I don't have a chip load for cutting aluminum on that. So what I did was I initially started with the V-Groove on the top using a too aggressive pass depth, even though it may have been a 16th. Well, 140 degrees, that's a lot of surface area, I came to realize. So I think I made 17 passes on the bottom to get this. And it's good. I've also learned about climb versus conventional cut. Climb cutting seems to work better, but a lot of further experimentation is absolutely required before I start to even initially understand this. So right now, the moral of the story is the flutes need to be shallower. They don't have to be this deep. Even though they're cool, they work, they're unnecessarily deep based on my experience of just selling thresholds for years. It looks too deep. I watched someone on YouTube and they referred to CNC aluminum machining or milling as a subtractive process. Yeah, when you're subtracting this much material off of a piece of aluminum, it's brutal. This bottom pocketing tool path, I think, took at least 3 hours. Now that's just not going to work. You can't charge enough money for this to make sense. So gonna have to think a lot more about the initial thickness of the aluminum, how much subtractive process actually needs to occur. I couldn't have made this out of quarter inch thick. I could not have, because the fact that it's a half sack. Because the height here down to here, that's a ½ inch. That's the problem. If this was just a plate, or if this didn't need to have this leading lip, yeah, I could have made it out of quarter inch. And the subtractive process would have been far, far less intense. So the fact that it's a half saddle is the reason why the subtractive process was so long, basically. So what I'm going to do next is I'm going to actually get the GoPro. I'm going to buff this a little bit by hand, just with a sanding block. In the future, what I've got to think about is this client specified no holes. Okay, well, that was easy, because I didn't have to think about any holes. I do have a countersink, I do have an 82-degree countersink. I do have, I'll be able to mill that. I'll have to think about fasteners, what types of fasteners to offer clients right off the shelf, to go with all of these. Finishing, I could polish that. That could become polished. It would look gorgeous. Polish it perhaps with elastics. Powder coating, that's something down the road in the future as well. So let's spend a little bit of time cleaning this up and see how it looks. Let's do that now.
If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video.
Actually, before we move on, I want to engrave the client's order number on the underside of it so that it's there.
really nice. Okay, so now I'm going to put a little TLC into this. While we've got the camera rolling, we're just going to continue on. All right, so let's take a look at the leading edge of this first. Leading edge is a little bit gummed up, and I can see that hitting it certainly isn't a bad thing. Smooths it out slightly, but not noticeably. But certainly doesn't polish it. I'll have to look into what aluminum polishing is actually all about. Really didn't do much but deburr it at the most. A little bit on the leading edge to see what that gives us. Yeah, it appears to dull the tool marks to a small extent. Yeah, I think what it does is just affect the way that the light actually hits the piece itself. Like I was saying, I'll investigate what aluminum polishing is like at some point. And really what I'm doing is taking off the markings that were on the aluminum from the mill, or from the supplier, I should say. I don't think there's a mill. It certainly made it a gray, but there must be... I'll be very interested to learn how polishing actually works on aluminum, because I want to be able to offer these as polished units. So that's just after sanding it slightly. Yeah, you can still see tool marks here, but they're all but imperceptible. Very, very slight. And again, probably a last pass. This was the very first cut that I did, so yeah, it's going to probably be the lousiest. On the bottom side, really not much here at all, except to flip it over, maybe clean up the inside. Bevel, V-groove. Gives us a real smoothing over. I believe the last thing I'll have to do is just nip these little artifacts off. Like I'd mentioned, one at each end. Beautiful. This is it. Blow it off with some compressed air. This job is done. Let's do that now. Get a final look at what it looks like when it's cleaned up to a certain extent. Ready to say that milling, machining is easy. But I am ready to say that it takes learning a skill in terms of how the material actually wants to be worked. Proper techniques, or the best techniques, I should say. I think this is it. But consider it a rental.
Thank you for watching, and if you've enjoyed this video, please click thumbs up, please subscribe, and maybe even send the video to someone that you know. Thank you.